So today we're talking about multiple angle and product to sum formulas. So our first ones that we'll be talking about are our double angle formulas. So jot these down. You will not be responsible for memorizing these on your test. I will give these particular formulas to you on your test. You should know your sum and your difference formulas because we've used them enough, but this is a one-day assignment. We're not taking 2 days on this section, so I'm not going to ask you to memorize these by the test day. You should know your Pythagorean identities, your reciprocal and quotient identities, sum and difference identities or formulas, but not these. So first of all, the sine of 2u, sine of 2x, is equal to 2 times the sine of u cosine u, or 2 times the sine of x cosine x theta, whichever variable you happen to be using for your angle measure. Tangent of 2u is 2 tangent of u over 1 minus tangent squared of u. But cosine actually has 3 options for you. The cosine of 2u is either cosine squared u minus sine squared u, or 2 cosine squared u minus 1, or 1 minus 2 sine squared u. So you're going to pick the one that's going to work the best when you're working these out. Okay, you're working with cosine. All right, everybody's got them written down? Okay, here we go. So on our first example, we're asked to solve 3 times the sine squared of x plus cosine of 2x minus 2 is equal to 0. So it looks complicated, but we're going to use this third one, aren't we? Because we want to substitute something in for this cosine of 2x that's going to be beneficial and helpful for the rest of the equation, right? So when we see a 3 sine squared of x, this is the logical one to use because we're not going to be introducing more cosines or sines. Okay, or more cosines. So the 3 sine squared x stays where it's at. But in place of the cosine 2u or 2x, the cosine double angle that we're going to use is going to be a 1 minus 2 sine squared x. Minus 2 equals 0. It helps you to put that in parentheses, which you substituted in, so you can see where things went. By all means, you can do that, but they're not necessary. Okay. So now what? Yeah, we're going to take these guys are like terms, right? And these guys are like terms. So if we have 3 sine squared of x minus 2 sine squared of x, we get sine squared of x. And if we have a positive 1 and a negative 2, we'll have a negative 1. And so now we can do what? We could use a Pythagorean identity if it was 1 minus sine squared x, right? But let's take the 1 to the other side or factor, okay? Either way, right? You can factor and say this is the difference of 2 squares. Sine x plus 1, sine x minus 1. That's probably the safer bet, right? Because if you decide to take the 1 to the other side, you have to remember that when we take the square root of both sides, we have to introduce that plus or minus. Either way works as long as you don't forget to introduce the plus or minus. Okay? So we ask ourselves now, where is the sine of x? For what angle of x is the sine going to be positive 1? So sine starts high, ends high, and starts low, starts in the middle, ends in the middle, and is low in the middle, and it goes up and down. So where's the sine? Positive 1 or negative 1? Pi over 2 and 3 pi over 2. Okay? So pi over 2 and 3 pi over 2 plus 2 pi n. Okay? Or we could tighten it up and just say pi over 2 plus pi n. where n is a integer, right? All right, so questions on this one? Does that make sense? Exactly. When they tell us that your domain is from 0 to 2 pi, then you don't have to bother with the 2 pi n, okay? And this one didn't specify, so we're covering our covering everything and going ahead and saying it. Okay, bless you. All right, so next one. Now we want to rewrite this expression using a double angle formula. So just like yesterday when you had some of them that were already, the summer difference was already written out and they wanted you to pull it back in and make it a single sine or cosine, right? Or tangent. Same idea here. They want us to go take it backwards. So if the 4 times the sine x cosine x is what we're given, which one does that look like? The sine of 2u, right? It's very similar to this, but it's what? Doubled it, okay? So you can think of this as saying that this is the same thing as 2 of these 2 sine x cosine x, and that's the sine of 2x times that 2. Okay, just twice as big. Okay, this is almost the same as this. So that here. Okay, almost the same as that, but it's twice as big, isn't it? So we just need a 2 times that sine of 2u. All right, questions on that one? To see problems like that today as well. All right, last type of problem involves power reducing. Okay. So if you have something like a sine squared of x and you want to reduce that power to make it a plain old sine of x, okay, no more squared, then you use a power reducing formula. And again, these will be supplied for you on your test. You do not have to memorize them by Friday. Okay? I've memorized a lot of things this chapter. So sine squared of u is 1 minus cosine of 2u over 2. And cosine squared of u is 1 plus cosine 2u over 2. And tangent squared of u is the same thing as sine over cosine, right? So if we took that sine of u, sine squared of u, over the cosine squared of u, this over this is going to become this. We flip and invert and multiply. The 2's are going to cancel. And we get 1 minus cosine 2u over 1 plus cosine 2u. So far, so good? All right, so let's see it in action. So now we're going to say, rewrite sine squared x, cosine squared x in terms of first powers of the cosines of multiple angles. Okay, so it's okay to have a cosine double angle or something like that. We just don't want to have any squared terms anymore. We're reducing our powers. Okay. So from our power reducing formula, we know that the sine squared of u is 1 minus cosine 2u over 2. So let's replace the sine squared of x with squared, but 2x over 2. And we're taking that times the cosine squared of x, right? So we're substituting this in. Okay? But we're not done. We don't just substitute it and call it good. Now we have to simplify. So when we multiply these guys together, first times first, they look like they're the same, right? But one's positive, one's negative. So first times first is 1. Outsides will get us a positive cosine of 2x. Insides will get us a negative cosine 2x. They're going away, aren't they? But last times last will be a negative cosine squared of 2x all over 4. Okay? So we're almost there. We reduced the power once, right? Both of those had a squared term, but now we're back to having a squared term again. So we have to use our power reducing formula again. Okay? Now here's what I would suggest. It gets messy when you have fractions within fractions, right? So this is like a common denominator of 4, right? So can we call this 1/4 times 1 minus cosine squared of 2x, factoring that fourth out? If I distribute that back through, won't I get the same thing? Okay. So now that we've done that, let's substitute our power reducing formula in for cosine squared of 2x, right? So we'll have our 1/4 and our 1 minus. Now, cosine squared of u was 1 plus cosine 2u over 2, right? So 1 plus cosine. Now, what's this going to be? You want to see why it will be a 4? Right? When we reduce it from a squared, it doubles the angle. So if it's already 2x and we double that angle, we'll get 4x. Does that make sense? Okay. So now we have to simplify. What's our common denominator in the parentheses? 2. So we'll have a 2 over 2, right? Okay. So if I take a 2 minus 1, I'm going to get 1, right? And if I'm distributing that negative through to both of them, I'll have a minus cosine of 4x all over 2. One is like 2 halves, right? So if I take 2 halves minus 1/2, I'll have 1/2, right? And then because of that negative is being distributed in, so it's going to be multiplied by that cosine of 4x, so it'll be a minus sign here. Okay? And then the last step is to actually multiply that 1/4 in, right? So 1 times the numerator is still 1 minus cosine 4x. 4 times 2 is 8. And we're finished. Possibly. Yeah, you could change that into a sine squared of 1 minus sine squared of 2x potentially. Okay, but then you've still got to go through and reduce the power again. Okay, absolutely. Okay. Feeling okay about these? All right. We can work another one of these if you want to see it. Otherwise, your assignment is posted also on your pink sheet. And away we go. And tomorrow we're going to review, and then Thursday we review, and Friday we'll take the test. Okay, absolutely. 1 second.